All right. Good afternoon. Uh, Once again, we meet for digital electronics. So today, we'll be talking of some little aspect of this digital electronics, whereby we will take a problem statement from the world. Then we try to apply the knowledge of digital electronics. We solve that problem, then we come out with an optimal circuit that will be used to implement such a problem or the solution to the problem. So let's see. Assuming we have a building or a house, this house actually want to apply some intrusion detection system. So we say that if I have maybe a human sensor, specifically a passive infrared sensor. So we know that when a human being walks towards this kind of sensor, some trigger should come out or a signal should be able to be triggered out. But then we utilize this signal for something else, whereby maybe there is an alarm in the home that we try to trigger this alarm. So this one becomes the output, then this sensor becomes our input. So let me say this sensor is called sensor A. Then the output becomes something like maybe Y. Now let's see. In intrusion systems like this, or in security systems, it's good we add a backup, or it's good we give layers of protection. So what we do is that we add another sensor. So let's say maybe under the carpets or the doormats, I try to put a piezoelectric sensor, whereby if this intruder even skips this, he might definitely step on this, so that this one will be able to determine whether there's an intruder in the house. So let's say this sensor 2 is called sensor B. So right now, I'm assured that these two sensors are going to be able to work effectively to be able to trigger the outputs. So this is our problem statement. How do I design the chip? Or how will I be able to design the electronic system or a combinational circuit that will actually implement the solution to this problem? So let's continue with that. So with this, I have to come out with what is called a truth table. This is my problem statement. But let's see, if I want to design a solution, definitely I have to start with something called a truth table, of which I should be able to register all the inputs and my outputs. How do I want the system to work? When A is triggered or when B is triggered, at what time do I activate the output? So we are going to look at that. But first of all, let's remind ourselves. If I'm having two inputs, it tells me that I'll be having about 4 combinations, strictly 4 combinations. Why? Because we know that number of combinations that you normally have is equal to 2 raised to the power n. But what is the value of n? N is always the number of what? Inputs. The number of inputs that we have here. So definitely our number of combinations is going to be 2 raised to the power 2, which is equal to 4 combinations. So that is what we are having here. Now let's see. It's possible sensor A will be off, sensor B will also be off. Now we are transferring the real world scenario into an electronic system. So what I mean is that it is possible that maybe there might not be any kind of intruder in the house. So therefore, sensor A is off, sensor B is also off. It's also possible that we may be having sensor A off, then we will be having sensor B on. The next thing is that we may be having this one too on, then this one too off. It's possible this one was able to what? To receive a signal. This one didn't receive. Then finally, it's possible that this one will receive the person, this one to receive, or they will all detect at the same time. So now let's see the output. Now you sit down with the one who needs the solution as an engineer or as a scientist. Sit with the customer. What would the customer want you to do with the output when these scenarios happen? Whenever I'm having this to be off and this to be off, the customer will tell you that at that point, let the buzzer or the alarm, let it be off. That is his requirement. The next thing is that you ask, what about if sensor A is off but sensor B picks? What should we do? The customer will tell you that at this point, you have to let it be on. The alarm should be on at this time because one of them has detected an intrusion. What about if A is 1 and B is 0? That one too, I'll tell him that he should on it. What about if all of them detect? This one too, I will say he should on it. Simple. So this is my truth table. We now transfer this truth table into what is called Boolean equation. So let's see. With Boolean equation, I have to increase this kind of table by adding one column to it. Okay, so we continue. What we said was that now we've gotten everything in the form of a truth table. Now it's left unto us to be able to apply what is called Boolean equation. We look for our Boolean equation. So we try to increase this table by adding another column to it. So let's do that first before we do the Boolean equation. So I add a column called mean term. I'm going to record the mean terms here. But what are they? I have M0, I have M1, I have M2, and what? M3. So what does it tell me? If I want to write my Boolean equation, what I do is that I'm going to have y to be equal to some summation of some values of the mean terms. But what are they? We say that always we look at the answers for what? Y. Where y is 0, we don't include such a mean term in our combination or in our summation. But we are going to concentrate on all the mean terms of which the value of y is always 1. So definitely we are going to add M1, M2, and M3. Then we discard M0. Why? Because M0 is having the value of y to be what? 0. So we have our values to be M1, M2, M3. But we all know summation to be equal to M1 plus M2 plus M3. Now we look at the combination of A and B that gives us M1. The combination of A and B that gives us M2. Then the combination of what? A and B that gives us M3. So let's look at that. If I look at M1, it tells you that at that point A is 0 and B is 1. Which tells you that we are going to have y to be equal to, since A is 0, we say that it is A bar. But at that point, we don't have B bar because B is having a value of what? 1. So we have A, B plus. So the whole of this represents our M1. Let's look at our M2. M2 is constituting A and B, but you see A is represented by 1 and B is represented by 0. So at that point, I call it A, B bar. Then finally, we have what is called the last mean term, which is M3. What does it constitute? That is A and B. But since they are all having their values to be 1, we say that they are represented by A, B. So this is the final Boolean equation for our problem statement. So this is the solution, or this is the beginning of our solution. So we are going to now transfer this into a combinational circuit. Then we draw it to see how we can optimize it.